All right. Yeah. Again, my name is Brenton. We'll leave mutes off for the moment in hopes that we can have an open conversation. And if you've got a dog or a baby in the background, maybe you take it upon yourself to mute yourself. Relatively informal here, so please jump in when you feel like you've got a question. Especially because we've got such a weird situation with the COVID scenario this year, and because we're kind of in the midst of 3 different programming platforms. I'm not going to get into detail about how to program, or I will do some specifics about how to build a robot, but not a lot. So we're going to kind of fly above things and kind of help you with more of an organizational, strategic level, not down to, is that the tactical level? I don't know. But if you have questions, go ahead and throw those out. I do have a kind of a PowerPoint slide that I'm going to set of slides I was going to do, and I presume that we could get that to you if you wanted. And of course, you can pull up your phone and take a picture of the screen that way too, or other means too. So let me go ahead and pull that up. And there we go. Again, that's me. And let me figure how I operate. There we go. So yeah, I was, there's a lot of words there, but basically it's about core values. What I was suggesting to Gene, who was first to arrive here, is that, you know, as a new coach, there is so much going on for kids and for you that don't give them an impression, you know, have a lowered expectation. You've got teams that have done this many, many years. And some of these are, and maybe you are too, a homeschooled environment where they are doing this every day. They're spending 2 or 3 hours at this every single day of the week. And it's not a level playing field in that way. And so you kids have got to detach and just see it as what they're going to get out of it for themselves. And if they happen to win a piece of plastic that a judge has deemed them to be deserving of, that's frosting. But set the expectation that they really are there to learn how to solve problems, work as a team, and have fun. Here, I've talked about building on the core values, which I really do think are the core of the whole program. You're learning lifelong skills that are going to serve in all sorts of environments. It's not about the Legos, right? It's about the project, the problem solving, and the teamwork, and that's the lifelong kind of skills you're trying to focus on. And you can, as a coach, then, in any situation, that if you give define your success that way, you can take about any environment, you know, happy or sad, and you can make that a winning situation for the kid, a learning situation for the kids. Sometimes when as teachers, when we set out to do a lesson, you know, we have lesson A we intended, but we get lesson B, and take what you get. Those are sometimes the most potent teachable moments. I had a team once who fought, and didn't do so well. Somehow the next year they wanted to work together again. I questioned them. They insisted. They did it. Fought. And then at the end of the year, we had so many conversations about what they were fighting about that they won. They were deemed the best teamwork award. I don't know. That happens sometimes. That was a few years ago. And in the 2020 and 2019, they framed the core values to discovery. I'm reading now on the slides: discovery, innovation, impact, inclusion, teamwork, and fun. Again, you can wrap any situation into those things and make it a winning one. You're going to feel stronger here and there. The kids are going to slide here and there. But if you can keep the focus on all those things, you're going to have a rich season. So that's not the focus of our talk tonight, but that is the framework for the entire season. And really, I think the purpose for doing what we're doing. Any thoughts on that or questions on that? Okay. With that in mind, I made it really people do this differently, and there'll be differences of opinions, but I really believe that if you want a team spirit, if you want to keep that, and have everybody be responsible and everybody supportive and everybody bought into what the project is or how the robot's working. You've got to manage it in such a way that everybody's involved with everything that's going on. You've got to have some ownership. Naturally, there's going to be kids that are more assertive or more comfortable doing this, and others will feel less so and more comfortable in a different place. But careful of those, we all know about those dynamics where some kids, because they're more assertive, they're not necessarily being pushy, but that can be the result. And so you as a coach, create opportunities where they're forced to shift roles. Sometimes, as I started, again, I taught at a middle school, and I would have veteran team members coming back and new ones coming on. And our first couple days, I would say, all right, you veterans, you got to put your hands in your pockets. You got to be involved, but you got to tell the newbies how to do it and train them up on things. And I think that's also important. Sometimes that robot, the research project is a big deal, and some kids really get into that. But the robot is kind of the iconic reason why we're doing this, what draws kids to it. And so I think that, whether or not they're a voice, sometimes kids can feel a little bit hurt if they're not the one at some point up at the table, pushing the buttons, aiming that robot. And so, I would suggest you try to make that an expectation that everybody has some mission run that they do. Oftentimes it's two people that are setting the robot up. So you can get two people going, and one of them's lining up the robot or putting the attachment on, and the other one's searching for the program. So I would work with doing that. Comments or questions on that? Okay. And here, and lots of words here, but basically, the point of this is this. Kids get in, they see the introduction to the game at the beginning of the season. There's all sorts of cool videos. Unfortunately, there might even be videos on YouTube that give them solutions. They get excited about that mission or the other. They have a really innovative idea on how to accomplish this, this mission, and they're anxious to go. And that energy, you don't want to squelch. You want to use that. But at some point, maybe sooner than later, you need to get them to think strategically. This is going back to those kids who are excellent builders or programmers. They'll get into the weeds and focus on that, but they haven't come up with an overall strategy. And you can really get off track on what you're doing on the map there. If they picked the mission that's in the far corner, that's kind of, and the toughest one there, they're going to spend a lot of time on that, and it may not result in anything. Whereas there are always built in, I think this year particularly, there's a number of missions that are quick and easy. They're close. They're just involving pushing or pulling. And I'm reading now a little bit, strategize mission selection. There's low-hanging fruit, the ones that are nearby, just out of base, that are close and easy. Or maybe they're easy to get to because they're along the wall. Or they're easy because it just involves pushing something or pulling something or navigating the robot to something. Focus on those, and those are good practice to see how your robot operates and fine-tune your robots. And then as they get confidence and skill in doing those things, you can have them move on to more difficult missions, and of course batch them together, either by location on the field, or if you can, use the same attachment for many missions at one time. Think about, I didn't put it up here, I'm still on that first major bullet there, by the way. Think about, I lost my thought. I'm going on. Have them, and there's a difference here on this too. This is my second big bullet. Rehearse 2.5-minute scoring rounds, not just individual missions. Naturally, and of course, now I have my thought again. Naturally, and of course, you're going to put a robot down and test it on a particular mission. And the kids may do that again and again, and they start to feel like they have success, and they say, "Oh, cool, we got 30 points." Well, what they're not accounting for is the fact that you got 30 points on the third try. Actually, after you tweaked the robot, how many times you moved it just a little bit this way or that way. And that's not a real life scenario. You've got to be in a game environment to really count that. And so what I'm emphasizing is on a pretty regular basis, maybe not right away, but pretty soon, get in the habit of, all right, let's do a real game scenario. I got my stopwatch, mark, set, Lego, and see how they do it. Because part of the whole thing is being able to do it quickly and efficiently, finding your program, changing your attachment, getting it lined up. I'll have more to say about lining up a little bit later. And it really is a choreography and a dance that the kids need to rehearse. One thing that's really opens up kids' eyes, even mid to late season, is when you get out and say, all right, not only am I going to time you for a 2.5 minute round, I'm going to another stopwatch, and I'm going to time how much of that 2.5 minutes the robot is actually out of the base. And it was pretty common at the beginning of the season that the kids are busy working, their 2.5 minutes is going, but 2 of that minutes, the robot's sitting in the base. And then kids can start to realize, oh, wow, it's, my scoring is not so much about the deficiencies in my robot per se, but about the handlers and how quickly and efficiently they can get those attachments on and find that program. And there's a couple solutions to expediting both of those issues. Just going down the bullet points there. So measure time, the robot is actually out of base scoring points. The third sub-point there, keep a record of the points earned to show progress of the season. I had in my classroom, and you might have something else, we made a column for each team and say, all right, here's the date. What was your score today? And then the next week, what was your score today? And they could actually see progress or not. And that keeps them kind of focused on, what they're really trying to do. Fourth sub-bullet there in the second main point, use a jig. I did not get a jig out. I'm sorry to show you, and I guess you're looking at that PowerPoint right now. Anyway, a jig, I'm going to grab you back just so I can use my hands anyway to show you. A jig is just any kind of Lego structure. Use some long beams and make it so it's not a rectangle that is not floppy. It's not going to fold on you, but it's fixed in size. And that is a device to slap down. And I mean slap because you're going to be kind of in a hurry. Slap it against the wall, maybe up in the corner, and then your robot can slide right up against that. And if they have that, and if they make that their starting point every single time, then they can be very quick about getting it lined up. Not this get down low with your robot like you're aiming a gun or something and tweedle and moving it this way or that, or even looking at the dots and lines, although that's better, on the mat to get it lined up. But something that they're not sitting there nervous in a game situation and trying to get lined up and doing it a little different every single time. Especially if you're in a practice environment and they're doing that, they line it up a little bit different this time, go back and make a program change, then come back and they line it up different again. And they're just doing these iterations that don't mean anything because it all has to do with how inconsistent they are being in lining it up in the base. So some kind of jig, you could slap it against the wall. The problem with that is that the wall is going to be there, and you oftentimes can't get your robot to turn away from the wall easily without getting disturbed. So if you have a jig, put the jig down, put the robot right next to it, take the jig out, leave the robot, press go, off and away you go. And that way you'll have a consistent kind of starting place there. Okay.
Can I interject?
Yeah. Oh, Kevin. Yeah.
So jigs are great, especially for new teams. There are so many variables in a Lego robot. Um, and yes, kids will try to aim that robot by looking down the line of it or pick lines on the mat to set the robot down. Even with a jig, if you are able to, within micromillimeters, set that robot down in the same spot every time and run the mission, that mission will land in different spots every single time you run it. The reason why, you have differences in battery at the time it's being run, differences in motor play, um, differences in how the kids may have touched it when they hit the go button. All kinds of things are variables that affect the robot. It's a plastic toy, for goodness sake. So it's not, while there's sensors and components within it to make it as accurate as possible, what you need to learn to do is try to overcome the deficiencies that are inherent in this plastic robot. It will vary a centimeter or two as it makes each turn. Me and my team sat and marked on the floor, starting at the exact same spot every time and running a mission that only was 2 turns, and it would still be over. A little bit to the left, a little bit to the right, a little bit to the left. So there's ways to remove frustration from teams, not only jigs, but there's ways to use the robot and the mission models to help center the robot, or essentially funnel your way into a mission model. And so if there's mission models where they need to be very exact on what they do, you can put feet on the bottom of the robot, essentially, that angle out. And as they drive into the base, the robot base where they're trying to accomplish the mission, those feet can then help center the robot so it accomplishes its mission. It's something I've seen many teams successfully do. The most important part, though, is especially as new teams, is look over the mat, pick your first mission that the kids want to work on, or first 2 or 3 missions, and start simply. The kids are going to want to try to do everything, and that can become very frustrating really quickly. So control how much they take in and try to do, and start simply. Even if they don't know how to build a robot, there are instructions online. Build a demo robot so you can at least learn how to program and go. And from there, they can tweak the robot and make it their own. But there's a lot to do in normally a short amount of time. So the goal is not to frustrate the kids, but it is also inherently stress in the design of the program, because it teaches kids how to deal with the stress. Okay.
And it, and I was, when I was using it, use of a jig is limited. A couple of things that Kevin referenced. One thing is that inside these motors, there are gears inside. And when you just randomly put your robot down, they don't fit exactly. They can be like this, or they can be like this. And so one of the other things I use with my kids is for them to set their robot down and roll it backwards or forwards, just a little bit into space. And then that will always put at least those gears into place. Another thing that Kevin was alluding to was that there's kind of 2 basic ways of navigating on the table. One is what people naturally start with, is what's called dead reckoning, which is basically, I want you to go out this many rotations, turn with this a number of rotations on the right side, and then go another so many rotations. That's dead reckoning. It has no feedback. That's a stupid robot in a way. But when you start getting into sensors, that is your self-correcting mechanism to get you back into line when you've lost your way, that it will inevitably happen. And that's, again, if you didn't, you already understand this, but that's why things down the table are so much harder than the ones nearby. Another tip that I'm going to come back and talk to some about kind of the construction of robots, but another navigational trick is, well, these are a little bit tight, but is using that wall to roll against. So have some wheels here that you can just have it slightly turned into the wall and follow the wall for as long as you can or need to go straight out of the base. There is some thought and trickiness on how you peel away from the wall, because depending on where your wheels are and how you are driving, sometimes your back end can push into the wall and it can be inconsistent there. Another thing that makes your robot very inconsistent is if it's floppy. A well-built, solid, stiff robot will do much better than one that's got play and is constantly falling apart and things like that. So the structure of that robot actually does make quite a lot of difference. Any other questions or comments?
Brenton, did you notice that Anupama has something in the chat that she was wondering if you had a jig to actually show, or a picture of one from the internet you can throw up or something like that?
Yeah, sorry, I don't have it right now, but I didn't pull one of those out, but I can send you a picture one. But it really is just a rectangle. I usually use two. Well, here I was building a robot that is I was building a robot frame, but I was doing something. You can use this strategy where you have two pieces that overlap, not by one unit, but two or more, and then they are not going to flex. And you can do that. And I would have done something here. I would use an L beam to make this corner stiff, and I would just make a rectangle of beams, 2 layers high, of whatever size, really doesn't matter. Probably smaller, but longer. And you just have that so you can push your robot up against it consistently. Lots of options there. Yeah, sorry, let me get that. I lost my chat window. Let me get that back up. There we go. Okay, and I'm coming back to get back on the points here. Use a jig is where we got off on there, I think. Creates, going back to, I said, bottom line, points per minute. The kids have to realize, that they get caught up into trying out one mission at a time, and they set it down on the table, and they, as I already said, they'll try it out, and they're not conscious of how they're tweaking it, and that it really took them 3 times to get it to work successfully. It's only when you really follow the rules in a real 2.5-minute session that they begin to see, oh yeah, I'm not really getting consistently all these points. It's not just that you have a mission that sometimes works, it's your success rate times the number of points that mission has, and then your success rate, if you're not trying something over and over again, then you are allowed to move on to another mission and score more points. And so that's an important thing to realize. There's a time factor there. How is your time being used? And that's why my emphasis is in points per minute. And that also goes to the idea of, next on my bullet list, is creating easier on and off attachments. I see it all the time. Everyone does. That kids are trying to change their attachments, and they may not have a good strategy to do that. And so when they peel an attachment off, they're actually breaking their robot and creating more frustration for themselves. So you want to be careful with that. I'm going to show you this model robot here, an idea for that. I have a couple things. I don't want to get too far ahead, so I'm going to talk about this whole list of best practices on a robot design that I think we have. But one is, I've got these beams oriented with the holes vertically. And so I can devise an attachment that maybe has axles that just drop right into there. Maybe they're not even snapping in. If I can get away with it, if it's not too floppy, I can just drop those in, and that's as easy as can be, as to taking it in and out. So that's why I like this kind of frame, is another reason too, but I'll come back to that here in a second. I'm gonna come back to my slides. Another thing in expediting that process and getting your robot out of base, and this might be subtle, but again, we're trying to shave some moments off of time. I'm trying to, make your team into winning ones with maximum points. there's a lot of time that kids are just pushing buttons on that robot, trying to find that program. And I think in these different platforms, I'm less familiar on how each of them does it, but there is some kind of system. I imagine that the first program loaded is first on the list, and then the next program is created and loaded is the next one on the list. But in the end, those may not be, that's probably not the way you will want to do it in an actual match. And so it would be good to clear those off, clean your robot brain off. You saved them on the computer, right? And then load them up in the right order so that they'll be ready to go. And it's not a difficulty to just go bing, 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 the first program, second program, third program, fourth program, and so on. And finally there, I said, have a solidly built robot that will save you lots of headaches. Any questions or comments on any of that? Okay. All right, and I think this next is the, yeah.
So are there any, excuse me, are there any limitations on the robot, like from Lego League? I'm just sorry, but I'm trying to understand, just getting into it. So are we limited by anything?
Yeah, there are, and I don't, those have changed slightly every year. This year, quite a little bit. And Kevin, do you know, can you jump in and talk to that?
I'm going to them, looking them up right now.
It used, yeah, they've made it happily that the rules are slightly different every year recently, and that's made it kind of fun and challenging for kids. I think that as the rules state, I would direct you to the challenge rules, the robot game rules, and there's going to be some explicit information about that there. Okay. And again, or not again, I haven't said this, but I would make sure that you have someone who's your rules master and who has gone through all those rules and really knows them, because they will come up, and that's the job of the referees, and they're going to go to the rule book. And it's really a bummer when kids have planned on A and then find out that A is illegal, but so you should have done B. Anything, Kevin?
Hold on.
There is a rule about all your robot and your equipment needs to fit in one of the bases. I don't think there's a height limit this year.
There's not. There are plenty of rules, and I'm sending the link to the actual game guide, which lists each mission rule, and hopefully, I think it includes the robot game. I mean, the robot rules as well. Should have in it. So some of these may be duplicated within the engineering journal and the team meeting guide, maybe not, but in the chat, I just posted a link to the game guide and all the rules of how the robot works. I mean, all the robot rules, game rules, points per mission, setup, all that should be in there.
Great, thank you very much.
And let me go here now. There is a real ethic in First Lego League. We really, I believe it, and I love the program because it is about that teamwork and that character element and those lifelong skills that I, as a teacher, was already, and I, as a parent, and you as a parent, at least, or a teacher, already in the mode to do. That makes it a winning situation. We really emphasize that. In fact, I have been in a tournament not too many years ago where we had a real problem because we had a parent that was too involved, and that one, it was an easy judgment. We witnessed the parent with his hands on the laptop, on the robot, repeatedly even. And that was a huge red flag, and we had to disqualify that team for an award they might have otherwise gotten. This is a big deal for us, that especially when you go to the tournament, and we sure hope at home too, that the kids are doing this. It's not and most people do understand this, it's not for the benefit of the parents, it's for the benefit of the kids. And, trying and failing is part of the thing too. So make the kids do it. Having said that, it is fair, just as in any industry endeavor, to know what the state of the art is. And so go out and find those resources. They're out there about how to build best robots. I've got a robot design here that I've used, and I've shown kids and said, look, if here's some place to start, maybe it's logical to start there, because unless you had some other better reason to do something different, which they eventually always do, think about that. And so now I also had the benefit of being a robotics teacher, that to be on the robotics team, you had to be in my class. And so I ended up teaching robotics principles in class, and then I wouldn't say anything at all when it came to actually robotics time. They had to do all that. But there are some basic principles to good design. Having a robot that's got equal symmetry, right and left, is important, because if you're not weighted properly, your turns can be less predictable, especially when you're trying to put on or take off heavy attachments. They can be thrown off that way. So try to maintain that symmetry, maintain that low center of gravity as best you can. Certainly have seen different configurations, but in my world, I was always pushing kids to do not use those treads, and let's don't do 3 wheels, let's do 4. They're much more stable and predictable. The treads I hated because that you get some inconsistent turning going on there. When you turn your robots on the wheels, you're doing what's called either a swing turn or point turn. A swing turn is where you have one wheel stopped and the other one moving, and that will rotate your robot around the center of the stationary wheel. That's your point of rotation. With a tread, where is that point? Where along that whole length of the tread is that point going to be? And it can be different depending on how the weight of the robot has shifted, or what it's carrying, or things like that. So treads are trouble. 3 wheels or 2 wheels and a skid or a ball, those work. I mean, I've seen people be successful with those, but there again, you have less stability in general. Same with, the diameter of the wheels. In general, I think you want large diameter wheels, because you're trying to get over debris sometimes, or climb up on things. Generally, you want larger diameter wheels. Could do it with smaller, but I don't know. That's my challenge is, you tell me why. Axle support on both sides. I'm going to show you my robot here again. I've got a wheel here that I've made this frame around the outside that is connected to the internal parts of a robot in a couple of places, in the back or the front and in the back. And then it's supporting the axle on the far side of the wheel, on the outside of the wheel, as well as where it connects to the motor here or up here, just to support on both sides. Excuse me, if you're not doing that, then when the robot sits, if let's say the outside brace is not there, you're going to get some bowing when you set it down. That is going to change the behavior of the robot too. So work on getting support on both sides. And what that ultimately means is you're going to end up having a frame. And I would suggest, have that frame, because then what you can do once you have this frame is you can back up into a wall and be square with the wall in some ways. Or, as I've already talked about doing, you can take advantage of the wall being there, as long as you have some wheels that give you a little distance and allow you to slide more frictionlessly that way.
I have a question about your robot.
Yeah.
So I see you're using 2 tire wheels
Okay.
and two different type of wheels. Which one is the other one? And what's the reason why you're using those?
Great. So thank you for bringing that up, because that's a great point. You'll note, I think if you can see it, I'll try to hold it closer for you. Here, I'll do it this way. That these are my drive wheels. They're the ones that are talking to the motor. That's going to propel my wheels forward. And actually, when I was telling you about the point turn, this wheel is stationary and this wheel is running. So this one, I'm going to turn like this, right around this point. Okay. And these are ones moving, right? Well, what's going on with these guys? They're scooting along the floor, not forward or back like they're meant to go, but they're going to be sliding across the floor. And if they have rubber, they're going to be grabbing onto the floor and trying to grab, but then they're going to bounce, and it's going to be really unpredictable. So we take the rubber off, and then you have a little bit more frictionless place to slide. But this one you want to grip because there's a drive wheel.
Oh, okay. So it's the same type of wheel. You just took out the tire.
It is. Yeah, it's a little bit. It turned out to be a little bit different, but yeah, I just took the tire off. Is all I was doing there.
Just different size of the rim, right?
Yeah, these are slightly different size wheels, but on all these kind of wheels, you can just take the tire off and just use the wheel hub.
Okay.
So
now,
yeah.
So last year, me and my husband, we coached for first time, and I'm debating for this year. I will decide after this meeting if I could do a handle or not. I don't know, it was a lot of pressure, but we enjoyed it. But we have a lot of problem with the wheel because we were programming as it's supposed to, and somehow the robots won't go the way we were programming. And we realized it after a lot of trial that one of the wheel was more worn than the other.
Oh.
Does that make sense to you?
Yeah. Or
so someone told me change the wheel tire, and then we did that, and it worked. But it took us a long time to figure out. Yeah,
or the mat could be dirty. Or the wheel can get dirty. Yeah. There is. I had one of my earlier years coaching. I did have a accelerated student who went through all 100 and some of our motors and ran a little test program to see, okay, if I'm telling it to turn 3 rotations, how many degrees did it really go? Because there are differences in the motor. This is not your issue, I don't think, but there are slight differences in the motor. This kind of goes to what Kevin was saying earlier, that there are differences. You could, if you have multiple motors in your kit, oftentimes you don't, you could devise some tests and see, and the important thing would be that they are behaving similarly. That would be helpful.
Okay.
One test or one thing I would often do with kids in class or on the team is that they would tell their each motor to go 2 rotations, 3 rotations, just do 5 rotations. Set it down, and they send it off, and that's the key thing. Consistently is not going straight. Okay. Well, if that's true, then there probably is a built-in difference to the motors. And so then I would tell, okay, that's your situation. So you from now on to go straight, you actually have to program to turn slightly to counteract that. So that's something you might need to be thinking about.
Caveat, first, they should inspect the robot to make sure build quality, that everything is tight on all sides and one side doesn't have something rubbing that the other side doesn't, because that will happen. So if you've ruled out any mechanical things in the way, then yes, it could be one motor that is not powered as well as the other. Other things that kids will run into and you as coaches is the motors can be placed, and I don't really have one in front of me right now, but essentially there's a top and a bottom to the motors. The motors really don't care, but when you're programming it, if you put the motor in what's considered right side up and you program positive power and how the robot's built, the robot may go forward. But if that motor's upside down and you put in positive power, that robot will go backwards. Really, it's all in how the robot's built, how you laid in the motors within that, whether positive power means go forward or positive power means go backwards. Because when you program within the built-in, I forgot what it's called now, EV3G programming blocks, there's power goes 100% positive to 100% negative, and that will affect whether the motor rotates one direction or another direction. So keep all that in
One
mind.
question. So we have Mindstorm, and we haven't bought the new robot, the Pipe Prime. Is now going back to motor, how it get built. Sometimes it get built not similar to get, I mean, the same exact way. That's extra challenge for us, for new team. Is it Spike Prime easier to handle? Is it always better built? I don't know how to say
I
it.
can't speak to that. I'm sorry. I don't imagine there's a difference in that regard.
As far as physically building, no, it's pretty, you're still using Lego technique. You're still building a robot. I have not used the Spike Prime. I've only seen a few trainings on it. To me, I find it more difficult because the interface is a bunch of little squares that light up on you. Really, there's a balance between what you can do with an EV3 versus what you can do with a Spike Prime. Spike Prime was specifically designed to lower the barrier of frustration to kids who are intimidated by the more technical look of the EV3. They both can do quite a lot of things. The Spike Prime makes it a little bit easier for teachers and students because the sensors are all smart. So when you program in, when you plug in a connector to a light sensor into the robot, you don't have to worry about which port you plug it into. Where on the EV3 you do. The EV3 has 4 ports in the front, 4 ports in the back. 4 ports are for motors, 4 ports are for sensors. The Spike Prime doesn't care, it has 6 ports. So you can plug in 6 things grand total. And whatever you plug in is smart plug-in. So if you plug in a motor, it knows, hey, I'm a motor. If you plug in a light sensor, it says, hey, I'm a light sensor. So those make it a little bit easier. It is programmed with a different language, but you can also use, it's programmed in, is it Scratch? Possibly Scratch, I think. But you can now do the EV3 in other languages as well, which I have not done yet. So really it's I don't have enough teams who've used Spike Prime yet to say if there's any benefit to it or not. We'll have to see.
Okay, thank you.
So would you recommend also, because I guess this is the set we bought, so we will be dealing with Spike this year. Are there any recommendable, I don't know, trainings or anything on YouTube that you'd say is worth watching?
Best place for training for EV3 or Spike Prime is a site called FLL Tutorials.
Okay.
And it is a site run by former First Lego League team, now a First Robotics competition team. These boys have been, well, I forgot what season it was. We had a season called World Class, and the challenge was to make learning better, easier. So this team's challenge was, how can we make learning First Lego League easier? They created a website. They started to create some lessons. Those lessons have grown now into where they're one of the most respected resources for learning. They also have a Facebook group that you can join as well. It's called, I think, First Lego League Share and Learn. They have one for First Tech Challenge, First Lego League Explore. And all those links should be on our website as well. And I will try to put them in the chat real quickly when I'm done taking over Brenton's time here. But yeah, there's a lot of great resources out there, and EV3 Lessons is one of the best places because they offer lessons for the coach. They offer team building lessons. They offer robot building lessons. They offer lessons for the kids on how to program the sensors, how to build the robots. They have a little of everything to help a team grow. So,
Couple, couple little details I wanted to come back and just touch on is that one recommendation about robot motor speed, kids will want to run on 100%. And there may be a moment when that makes a lot of sense because speed or time is a factor. But as you might suspect, it does not run as reliably that way. You get, skid starts and weird things happen. So I have seen some teams even do kind of a ramp up and don't start at full speed right away, but start at 25, 50, then 100 or something like that. Or most of my teams just ran at 70 or something like that. So just don't run at full speed. Also, jumping way back when I had a thought that I'd lost and then got again. Naturally, when you're starting out, you're going to start from the base and you'll do one mission at a time, and then you'll start to batch those together. You as a team need to think about, okay, well, what if I've got a mission run that I've got 3 things I'm going to do on that? What if I'm successful at 1, 2, but not the 3rd? Then what do you do? Do you run? Sometimes you really just can't. Do you run that same mission, that program that's going to go 1, 2, they're already done, and then the 3rd again? Or do you have you made a new program that just singly deals with these things or that things? Think about that. Also, it is my experience, and again, the rules might change or how you deal with this, but every year it seems like it's useful to have a program that I have my robot in base and it's got a loop and it goes out 12 inches, puts down a giant net and slides back, because inevitably things get dropped around the base that you want to recover. And so having just one program that just basically does that drives out, puts down a loop, and then pulls back to base, that's often useful. Okay, let me jump back in here. I just have a few more slides. I see our time is running short here, but this was the big thing. So symmetry, low center of gravity, 4 wheels, large diameter wheels, axle support, rigorous construction. Oftentimes that means doubly reinforced, not just one connection, but multiple. We talked about the attachment options for your attachment options, making them quick and reliable. And we also talked about the wheel bumpers that allows you to follow the wall. That can often be very helpful. Or you could back up and having, didn't list there, but having the frame, a rectangular frame around the whole robot can be useful, because then you can back into the wall and square up at any time. Any questions on any of that? I think we'll shift into the programming and then we'll kind of wrap up. And I don't have as much to say on the programming because they're all general kind of statements here. Oh, okay, yeah. Robot programming, use a jig. Because if you're not, really what I'm telling you there is start consistently every single time. Being repeatable is really, really important. If you're monkeying around each time, then your programming is for naught, because you're, as Kevin already was alluding to, you already have a certain error that you're trying to work within. And if you're adding to it every time, it's going to be really hard. Clear, Untitled 1, Untitled 2, Untitled 3. If you didn't, think about it, those are terrible names for your robot programs, and kids will fall into that. And they'll have creative names, but they do need to have unique names. They'll have their own language, but they do need to have names that they know what they're talking about, because I've often had too, when you're out on the robot table, kids choose the wrong program and now they got to reset everything and they get a touch penalty and unnecessary upset. Oh, and then regularly back up your programs. I've had this too, very painful experience that their flash drive gets lost or broken, and they've lost the programs on their flash drive and they have nowhere else to get them. They might even think they can retrieve them from the EV3, from their brain of the robot. Yeah, that would be a really cool feature. Doesn't exist. I've seen hints of, oh, it's going to happen, or he's supposedly, there's myths about it happening, but it never does. And so you can't pull it off the robot and put it back on the computer. There's a compiling issue there. So back them up. Another thought, use MyBlocks or other, I'm not sure on the other platform. MyBlocks is NXTG or EV3G or whatever it's called these days. The programming environment that comes with, it used to be kind of standard. That's called a MyBlock. What you can do is you can have a series of blocks that you're going to do routinely and just give that a name. It's called a MyBlock. And then you can just refer to that one thing as opposed to, and it gets its own little special block, as opposed to having to make it all from scratch. There are some tricks with that, because if that MyBlocks has to travel, has to be on the computer and the robot for it to work, because if you're trying to reference it, but that MyBlock arrangement is elsewhere, it won't work. But having those can be helpful in expediting your thinking and organizing. And with that, this is a biggie. Have them use the annotation features in their program to, draw a bracket around these blocks and say, okay, here we're going straight. Okay, here we're turning. Okay, here we're spinning the wheel, or whatever the mission is. But make it explicit, not just for them so they can quickly jump in and see what's going on for each other and on the team, but, and this is especially, I think, important, it helps the judges. I've seen judges that are coming down and they're looking at just a dozen blocks that, have all sorts of configurations, settings in there, but they can't tell what's going on. What purpose is there in the judge even looking at that? It's just a series of blocks. But if the kids have made it clear, okay, first I'm going out to this area, I'm squaring up with a wall, and it's written on the program. It's very helpful. You're scoring points with the judges by clearly communicating to them what's going on.
Oh, by the way, if you didn't know, your team will be judged on robot design and programming, as well as their core values and their project presentation. So this year, something's a little different. With or without the virus. First has changed the rule to where judging is now one, I believe, 30-minute session. Your team will be in with a team of judges presenting their robot design, their programming, their core values, and their project all in one session. So throughout the season, it helps to take good notes. What judges look for in the robot side of the house is not that you just walked in with, hey, this cool robot we made, but how did they get to that cool robot? What lessons did they learn along the way? How did they learn that bigger or smaller wheels work better for that robot? How did they learn about this kind of sensor, and how they put it to use, and how they make their code more efficient? Those are the kinds of questions the judges are going to want to ask. So the team in each meeting should really kind of keep notes, in addition to the engineering journal that FIRST provides, really meeting notes that basically say, here's where we started with today, here's what we worked on, here's things we tried that worked, that didn't work. And then you consolidate all those notes by the end of the season, present it to the judges and say, this is what we learned throughout the year. Because really we care mostly about the fun you had and the lessons you learned. So that's my little spiel.
And as a lead in for, I think this is about my last slide here, but yeah, if you're preparing for this robot design interview, and it used to be, I have my kids to show up and be ready for answering questions, but really there's such a wide ranging assortment of questions they might ask. It's better if the kids come in with ready to tell their story, as Kevin was saying, is how did your robot evolve, and have them direct the conversation. So it's not quite a research project presentation, but a little bit. They should have their materials organized to know what they're going to say and share that. And with that, I think that's about it. And I think we're a little bit just my big things I'd like to hammer home is, get everybody involved, work on that reliability, and just repeat, and rehearse and practice your choreography and getting your robot game done.
So I had a logistical question. And I'm sorry if I missed it on any of the updates or emails, but are there going to be competitions in person this year, or is that still up in the air? And if there's not, what does the alternative look like?
Kevin, I think
Do you
that's
want to take that, or do you want me to take it?
Sure. Catherine, yeah.
Catherine, can you take that?
Yeah. So Wendy and anybody else, if the communication hasn't been clear or you feel like you've missed a communication, please feel free to email me at programs@coloradofirst.org and ask follow-up questions too. But our plan for this season, following first announcement that they overall are extending the season, that allowed us in Colorado to also make that decision to extend our season. So we will not have the typical competitions for First Lego League Challenge in November and December as we usually do. Right now, we are anticipating that the state competition for First Lego League Challenge will be in April. And if we have enough teams register that we would need qualifying tournaments prior to state tournament, those would not happen before February. So those would be taking place, if they need to happen, in February and March, hopefully around spring breaks, if it needs to be in March. And we do not have dates for those nailed down yet, because we're really trying to see how things will come together the best way for the kids. We want to make sure that we're using our best options to make those competitions the best that we possibly can for the kids. And so we will be communicating with all of the coaches, all the volunteers for those tournaments as regularly as we can. As soon as we know decisions, you will know them as well. And if you feel like you're not getting information, you can always email me and I'll say, yeah, hey, this was the latest communication, or no, we haven't decided that yet. Does that answer what you needed, Wendy, or were there some follow-ups you wanted to ask?
No, that's great, and I'm sorry if I missed that. I just get inundated with information, so
There's a lot going on, so don't worry.
Yeah, so I'm actually at this point just planning on doing this for the first semester at our school, and so is there any kind of virtual like presentation or things that we could do if we opted not to do the in-person in the second semester, or is we would just do it as a club and kind of see what we can put together on our own at this point?
I think that I missed the first part of that. I don't know if my volume isn't working quite right. It's probably my laptop.
We're planning on doing this for the first semester, so I just didn't know if there was any kind of like virtual presentation or thing that we could do to kind of conclude it for my kids in lieu of going to a competition in the second semester.
You know, we really don't have anything that would work for first semester, because with the remote aspect of things at this point, First is developing what they call the remote event hub that will be sort of the overarching structure for how we can do remote events if we need to, even in the spring. And they're working around the clock on that, but they are behind their original schedule. And so it will not actually even be released to us until December 1st, they're thinking now. And even with that, it'll just be a beta version that will not have all the improvements and all the bugs worked out that they are hoping to release for early 2021. And so, so that makes it really difficult to try to put something together for first semester that would be a viable, really, impactful experience for the kids. I don't know if Kevin has some other ideas, but what I might suggest to you is if you can maybe make some videotapes of your kids doing, say, their research project presentation and doing some sort of presentation about their, robot design and their strategies, and you can videotape your robot runs, on the actual robot thing, and then archive those, so that when we do have some competitions and whatnot, you have those things to work from. And if we have something that's totally remote, you could certainly send all those files in and go with it. If it's a sort of a combination of factors, you could always get the kids back together again and use that source material that you've archived, and then just supplement it with the kids being able to kind of, tell their story from that point. Does that make sense?
Yeah, that's great. Thank you.
And any other questions?
You
Anything else?
mentioned
Go
you
ahead.
mentioned a first engineering journal. I haven't come across that. Is there a website or a way to get my hands on one of those to make sure we're following, or should I just be taking minutes and have the kids put it together? Is it in the engineering notebook?
Yeah, each team in your, when you register, you should get, I believe, 2 engineering journals, a team meeting guide, and the robot game rulebook.
I got those 3 that Brenton's showing us, but I did not receive
That is
a
the guide
journal.
we were talking about. That,
Oh,
so the
okay.
engineering notebook, engineering journal, same thing.
Okay, thank you.
And Brenton, did you maybe mention in some context that some teams may make an engineering journal that's not exactly that engineering notebook? They might have their own kind of template for how they like to keep track of their evolutions of thought.
I didn't explicitly mention that, although I did mention that being ready. I think that is increasingly what people are doing when they come into robot design. Having a plan of some sort, a presentation, and having notes and examples of the evolution of your robot is really useful. So judges can see the insights of thinking, the learning that's going on, development of your robot. So writing that down obviously is great.
Last season was the first season where we did the engineering journal, where it was produced by First, and they gave like 10 per team, and teams would try to walk in for the judging and hand the judges over those engineering journals. Well, judging sessions are so short, you don't really have time to review all the kids' little notes written all over and colored all over the engineering journals. What the journals are really for is it's a tool for you, your team, to use to help manage their season, manage each other. It's a guidebook. It's not necessarily a rule book. Use whatever format works for you guys. I will tell you that as you're running your meetings, coaches should read the team meeting guide and the engineering journals and know them both pretty well, because they kind of refer back and forth to each other, and you may get to session 1, group 1, if you want to follow the format that they use in the journal. It breaks your team into different groups. And the first thing it does is have group A or group 1 for session 1 start to build a robot with no instructions on how to build the robot. Those instructions are within the Spike Prime or the EV3 or the Lego website. So you have to prepare to get all that info if you want to follow the path of the guide. So not everything's in the guides that you will need, and you need to know enough in advance that there's some gotchas in the process. So First has made some great strides, but they put out some landmines in your way in the process. So don't be afraid to ever ask, and email us, email each other. While we may compete, we're also cooperation is a term of First. Because really we're all about making all the kids and all the coaches have a great time. We want you to come back again next year and do it all over again. We want all the kids to come back. We want them to go through long enough that they can enjoy the scholarships that First offers every year. So keep your kids involved, and it's a benefit for us all.
I'd piggyback on that a little bit, and I'll say, as a first-year coach and team, there are a lot of. What's awesome is there's a lot of great resources here. There are spot on the directions you should be going, but a lot of times as a first-year team or coach, you're just trying to get through the season, and there's a lot here. So just keep those kids happy and busy, and move forward, but don't feel too overwhelmed, especially in this situation this year where we've got so many variables you're trying to work through.
Remember just to have fun.
Brenton, back on some specific questions over in the chat. Anupama's asking, her team wants to know, does the robot have to drive only on the black and white lines to go to a mission, or is that simply a strategy and a helpful thing that some teams choose to do?
Now, Yeah, not at all. In fact, most teams, in my year, I was at campus middle school coaching for 6 or 7 years. And every year I was trying to get my kids to use sensors, and more, as a state, you see more and more robots making extensive use of sensors, and those who are most successful are doing that. And the sensors I'm alluding to a little bit here with your black and white lines are the light sensors there. But honestly, the vast majority of my robot teams did okay, and they did not use a lot of sensors. But boy, that the bar keeps increasing every year, because more and more we have these little schools or enclaves of community where coaches have been doing it for a long time, and there's some history, and the bar is going up, and making resources like this has been helping too. So no, don't worry about those black and white lines. They're only there to provide an option for people who want to use light sensors.
And if they do want to learn more about those sensors, those websites that Kevin put into the chat for FLL tutorials and Spike Prime lessons are great places for you guys to learn about how to use sensors and such like that.
Yeah. And well, side note, if you can get 2 light sensors on your robot, it'll do better than just 1. But starting to get in the weeds there. Anything else?
What are the sensors that you would recommend for beginner team? Because I found that last year we tried to use so many, but that's why I guess we got overwhelmed because we didn't have time to learn all of them.
Yeah.
And so what would you, if you would choose 1 or 2, what would you recommend?
Touch sensor, light sensor.
Touch sensor, light sensor.
Yeah. Their gyro sensor is good in theory. I would be jumping all over that, but it's been weird, and I don't know if the new generations of stuff might have something better now, but
more problems with the first one than there were with the second one. So the gyroscopic sensor can work, but there's many issues that can happen with it. The color sensor is really the best sensor to start with, because they can do so many things with it. They can follow those black lines.
Color / light
never
sensor.
use touch sensors because there's ways around them, but a touch sensor is an easy sensor to learn. So I would recommend actually the light sensor as a great addition to the team if you had to learn any one sensor.
Is the light sensor same as the color sensor?
Yeah.
Yes, it is.
Yes. Okay. Thank you.
I also noticed in the chat just briefly that Anupama is asking about the dual lock. I have an email from First, Anupama, that says that First will be sending teams replacement dual lock this week. I don't know if that pertains to the problem that you're having, but hopefully that will be alleviating the problems. And so it says they will ship an additional piece of dual lock to every team that has purchased a challenge set. And they will continue to do that with every future challenge registration. So I don't know, Kevin, if you're aware of any issues they've been having or advice there.
I do not. I was not actually aware of the issue.
Okay, so hopefully that'll at least fix your problem, Anupama, but let us know if it doesn't, okay?
Okay, and I just had one more follow-up on that. I don't know how to put it, so we just have to like take it and put 2 dual locks on each, or do they give a specific location where we need to put the dual locks when you stick the model on the mat?
Ben, can you show the mat?
Yeah, let me lift you up here a little bit. On the 20, you see that? Okay. On the mat, there are places where there's a little square that happens to be perfectly sized to a dual lock section, and there's an X through it. So put those all over the map, wherever you see the X's. Then what I do is get another set, same number for, there's a set of 4 here, get more dual lock. You have to be kind of careful because you don't want to stick to your fingers, but set it upside down, Velcro kind of idea. So it locks in there, put it in place, then go get your already built mission and very carefully line it up, because once you touch it, it's going to stick to those dual locks, and then push down firmly. And now the sticky is sticking on your mission object and you're good to go.
Thank you. Yeah, that makes sense. Thank you for the demo. Yep.
Okay. Well, I guess
I
that's
also had
it.
one more last question. Can I go ahead? Okay.
Yes, please.
So our team was practicing turnings this week, and they observed that if they have to make a 90-degree turn, so they have to really give like 360-degree or some other number, and then it turns 90. So is that okay, or we are missing something? Like I don't know. We are still figuring it out and learning, but I just thought to see.
Yeah.
Is that how we? Okay.
Well, here's the clarification. Common comment. If you're new to this, this is really new. You're talking about having a robot turn 90 degrees, right?
Right.
Okay. But you're not programming that way. You're programming the motor, and the angle of reference there has to do with the wheel turning that distance.
Right. Right.
For those of you, I didn't get into the, oh shoot, I don't have any power on that one. I didn't show you how to do port view. I didn't get into the programming in different platforms, but on EV3, there's a very useful feature called port view, where it's a measurement tool, and you can put the robot down and then by hand push it while you're in port view, push it to where you want it to go. And you can see, you can read on port view how many degrees of rotation those wheels are going through, and then you can go back and program it to mimic what you just did with your team.
Sure, I think, yeah. So we tried that, but we just wanted to make sure that the number really won't like 90. I mean, you have to do 360 to get a 90-degree angle.
Maybe.
And you have to do some more to get a 180-degree angle. So just wanted to make sure.
And and then there's different way. Now, this is going back to my classroom days, but in the simplest turn is to keep one wheel stationary and just move this one. And you get a different angle to make your 90-degree turn. You get a different angle needed for this wheel to do that. Then if you do one of the other strategies, which maybe has this one going slower but not nothing, and this one going forward, it'll be a different. Or you can do what's called a point turn, or something like it, where this wheel's going opposite way while this one goes forward, and then it turns right in place. So it depends on what style of turn you're doing there.
Okay. All right. We'll explore that. I think the kids were trying pivot turn and spin turn this week to see which situation they should be using which turn.
Yeah. Okay.
Thank you.
Yeah. Anything else? These are great questions.
By the way, that's a great learning opportunity where the team can determine, each robot is going to be different. So if the team can determine how many degrees of the motor in that style of turn where one brakes and the other wheel does the turning, how many degrees that motor has to turn to get the robot to actually go 90 degrees, you can then program that into a My block so that you know forever going forward how many degrees essentially. So if you want to go 30 degrees, that My block can do the math for the team. So
you don't have to do it like every time.
It's been a while since we've done it, but you can make a My block that would then mathematically calculate out the degrees for you, so that you can just program in and say we want to go 30 degrees, and it would go 30 degrees, doing the number of, not rotations, really number of motor degrees to get the robot to turn physically 30 degrees.
Oh, that's a cool feature. Yeah, we haven't yet reached My blocks. I don't know if we will, but that's a good tip that you can use it throughout your program then. Yep.
So I feel like I'm going to have more questions as we get through it. Are there opportunities to have tag ups like this in the future?
Sure.
And, Kevin, Catherine, you can
Yeah.
forward on my email, anybody who, would want to ping me if I could be of assistance, but there are other resources too. And there's other sessions, or are there not, Catherine?
Right,
There
absolutely.
is,
And
and there
Brenton,
will
thank
be.
you for giving us license to use you as a future resource. That's always helpful. I know Ruslan did the same thing with the folks in the advanced session. We are totally planning that these coach conversations are a regular feature throughout the course of the season. This is our third one. In case you missed the first two, we do have recordings of those that we're working on finding a home for on the website. But if you are wanting those, you can email me and ask for the links to those first two. We will change the topics each time. So you may have seen that we sort of advertised the next coach conversation will be on the project, the research project and the innovative solution, because we do want to balance all the elements going on for your team. So that one will be in the coming weeks here in October. And then really we want your input, because we want these coach conversations to be useful for you as coaches. Some of them that we have are more a format of brainstorming, and all the coaches are really talking together, and we have little chat rooms where they're all sharing their common experiences about things. Others are more presentation based, like this one, where you're really trying to learn from a more experienced coach and asking those back and forth questions. So we really want to hear from you guys on what topics you want on these coach conversations. If you ever feel like you'd like to lead a coach conversation, we really want to hear that too. If it's a more discussion oriented one in those chat rooms, we're just looking for leaders for those rooms that want to kind of keep the conversation going, but you don't have to necessarily know anything. You're just there to help the conversation. So really, we want to hear from you. Let us know what you want in these coach conversations, and that may change as we go through the season. You may come up with some things that you really need to know about 2 months from now that you didn't even think about now. So have that line of communication with us be open all season so that we can serve you better.
Put my email in the chat, and also if you guys can't find my email or anything else on our website, coloradofirst.org, First Lego League, if you scroll down a little bit, there is a contact us section, so you can ask questions there, and we'll be able to answer through that as well. So just never feel frustrated. Ask anybody. Somebody will help. We've been there.
And there's my email, and looks like Catherine's there too. All right. I guess that is it then. Thank you.
Brenton, thank you so much for all your wisdom and expertise. Kevin, thank you for chiming in with your wisdom and expertise. That was awesome. Really, really appreciated that. And thank you everybody who attended. I will be sending out the link that will have this recording in case there were parts of Brenton's slides that you wanted to look at again or something like that. And otherwise, just thank you everybody and have a wonderful rest of your night.
Thank you.
Everyone.
Bye.
Thank you.
Thank you. Bye.